欢迎来到建筑会的直播间，我是主持人 Lily。随着现代生活的快节奏我们大部分的时间都在室内度过，而室内的这个空气质量呢，会直接影响我们的健康跟生活品质，因此了解并改善家居的空气质量变得至关的重要。Okay, sorry, I'm just gonna check if people are online. I'm just checking at my end if the link works.Yeah, it's on. Okay, cool. I will restart. 后花园线上的朋友们，大家下午好，欢迎来到建筑会的直播间，我是主持人 Lily。随着现代生活的快节奏，我们大部分的时间都在室内度过，而室内的空气质量会直接影响我们的健康跟生活品质，因此了解并改善家居的空气质量就变得至关的重要。本期呢，我们为您详细介绍 SmartVent 家居空气净化系统。我们请到了 Simex 旗下的品牌 SmartVent 的市场部经理Storm Happen，以及市场部的经理小慧赵。Storm 在大学学习了 engineering 的专业，所以他对室内的这个潮湿环境等以及新风系统背后的成因和原理有着更深层次的理解。今天的直播内容呢，也是会由他来主讲。Welcome to our webinar today, ladies.
Thank you. 大家好。
那么我们 SmartVent 的系统呢，分为两大类，正压式的新风系统和全热能交换的新风系统。不同的系统适用于不同的房屋设计和居住人群。通过 SmartVent 的产品，可以有效的提高室内环境的舒适度，还能够降低房屋的能源的损耗。好，那么我们现在这边来确认一下我们的观众能不能看到。Okay, just give me a second, and we will just check if people are actually in the webinar. Just 1 second, I'm just checking with the IT team because I received a person saying that they can't log in. So just checking if there's any IT issue. It should be fine. OK, 如果有现在已经到直播间的朋友们呢，请大家稍微的等待一下，我们再检查一下有其他的观众有没有这个登录的问题。我们的直播正式的内容会稍后开始。Okay, so my colleague you can't log in?
No.
Okay, just 1 sec. It has started. It says it's live, but 2 links are not working.
Yeah, I've got the same issue as you.
Yeah, but there's other people that are already in the webinar room, so there's 14 people that could log in.
I see that.
Yeah.
I'll leave it with you guys.
Okay, we're just gonna wait 1 more minute because for some reason there are most people that can enter the webinar room, but 2 at my end, so 2 of my colleagues couldn't enter, and but it works fine for my end. So 对，你要用 app。Okay.
Okay, if anyone who's online already had any questions, I could answer them at the start while we just wait those few minutes.
Wait, let's just wait for a minute because I think the phone app works, but for people that's entering using the Google Chrome link, it just says there's an error code. I'm just gonna take that picture and send it to my IT support.
Always love technology. Never plays games when you never plays ball when you want it to.
Censored. Because censored you're in the hour or almost 5 o'clock.
Yeah, we've never had that before because previously if we have any issue, it would just be the internet's not really stable. And the IT just replied, it says it shouldn't be any error. It it, 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 Okay. Okay, so 对我们现在正在直播间等待的朋友们，请大家稍后片刻，我们的直播马上就会开始。后花园那边是没有问题的。Okay, they're just gonna run a test, but we can probably just, I'm gonna restart my intro and hopefully more people will get a chance to enter, and then we will just kickstart. Because the other thing is they can always come back and watch the recording. We have everything recorded. Yeah, cool.
Excellent.
Yeah. 好，那么后花园线上的朋友们，大家下午好，欢迎来到建筑会的直播间，我是主持人 Lily。随着现代生活的快节奏我们大部分的时间都在室内度过，而室内的空气质量会直接影响我们的健康跟生活品质，因此了解并改善家居的空气质量变得至关的重要。本期呢，我们会为您详细介绍关于 SmartVent 家居空气净化系统。我们请到了 Cymex 旗下的品牌 SmartVent 的市场部经理 Storm 以及市场部的同事小慧。Storm 在大学学习了 engineering 的专业，所以对室内的潮湿环境的成因以及新风系统背后的原理等等的有非常深层次的理解。今天的直播内容也是由他来主讲。那么 SmartVent 的系统呢，主要分为2大类，一个是正压式的新风系统和全热能交换的新风系统。不同的系统适用于不同的房屋设计和居住人群。通过 SmartVent 的产品可以有效的提高室内环境的舒适度，还能够降低房屋的能源损耗。好，那么现在我们的直播的演讲的内容即将开始，我会开始分享我的屏幕，也欢迎大家在直播中来登录后花园提问，我们会尽量的去解答。Okay, I'm gonna start to share my screen right now, and let's see it.
Excellent. Thanks, Lily.
No worries. Cool.
Brilliant. Well, look, thank you so much for joining today. I'm from SmartVent. My name's Storm. You will have got that from Lily's introduction. And I've got my colleague Hui here to help make sure we get everything over the line. And I'll be taking you through the SmartVent product, but also a little bit of the education behind ventilation and how it works. And I like to start with that because I find it's really helpful for people understanding what a ventilation system is actually going to do for you and which one you might be choosing for your home, and understanding the differences between the types of ventilation systems on the market. So if we just have a quick look at what SmartVent does for you. So SmartVent has been around for almost 20 years now. We've got a very trusted brand in the market, and we're available locally throughout the country. And we actually sell through wholesalers into accredited installers. So you can be talking to your own preferred electrician, and they can do the job for you. One of the things that I loved about SmartVent when I first joined was the really wide range. And the reason for that is that I know I can recommend people the best solution for them. In fact, same for the installer. You can recommend the best solution for the home and for the homeowner rather than only what you have on the market. I also really like the control system that's available. So it's a very clean control system, very modern. And so we've got multiple options in that range that allows you to get advanced controls over your home ventilation solution. And then, of course, if you do need any assistance, we have an 0800 number as well as local support in your areas too. Now, when I'm talking about ventilation, I'm talking about why ventilation matters. So one of the things that's become obvious to me is that the first thing people talk about is moisture. They think condensation control, condensation management, and then they go, yeah, we'll get rid of mold, we'll get rid of mildew, we'll make my home drier. And that is absolutely one of the things that's really important about ventilation, something that will help with, and I'll take you through how that works. But what I want to highlight for you are some of the other things that that ventilation also helps with. So when we had COVID, we found there was a massive peak in the number of people speaking about ventilation at home. And from that, what we've found is actually that people now understand that bacteria and viruses are one of the things that when we replace the air in our home, so a ventilation system is replacing the air in your home with clean air, preferably clean air from outside. And so it brings that air in and it removes the old air. So what you do is you reduce the concentration of bacteria and viruses in the home. Same with contaminants and smells. Maybe you've got a teenager with a shut-up bedroom, or you've burnt the toast. there's a lot of different ways that that contaminants and smells can build up in our home. Then we've also got something called VOCs or VOCs, and that stands for volatile organic compounds. And basically what they are is they're chemicals that come out of fresh furniture, new paint, air fresheners, that we put those contaminants into our homes when we're living in it. And so that can get into our lungs and cause irritation, and it can also cause headaches. But the last one for me that I find really important, really critical to talk about, and I've actually got with me today, I don't know if you can see it, is a CO2 monitor. Now this is just one I've got online, but it allows me to see what the concentration of CO2 is in the room. And the interesting thing with CO2 is there's a healthy level of CO2 between underneath about 800 parts per million. So the number that you'll see on the screen is in parts per million. So you've got, what have we got there? 450 parts per million on the screen. So 450 is great. That's a very healthy level. But when you reduce ventilation in a space, or you have a closed up space, you're not opening your windows, or you're not running anything to replace air, then that CO2 level can build up. And when that CO2 level builds up, it creates headaches. It causes you to concentrate less. You know that feeling when you're starting to get tired towards the end of a presentation or a lecture? Well, if you're getting tired towards the end of the session, I'd recommend you check your CO2 levels or you open a window, because it's not because I'm boring. It's actually because you've got too much CO2 in the room. And again, with CO2, the reason for that is our body takes in oxygen. When we breathe in oxygen and we consume it for our brains. And then when we breathe out CO2, and it's our waste product. So you build up that CO2 in the room and your body, essentially your brain starts starving. So CO2 is really, really critical. You can't see it. You don't always associate it with ventilation, but it's one of the main things that ventilation helps with. Just like when you're trying to study or work from home, you want that higher level of oxygen in the air, not a high level of CO2. So ventilation helps with that as well. But if we want to talk more about what moisture is actually doing in our home, so if we just go to the next slide, we'll have a look at the different volumes of moisture we generate. So I talked a bit about the different types of contaminants we generate when we're living in our space, but moisture is a really interesting one because that's the hot topic for everyone. And what I find interesting about this slide is that, have we still got slides? I just want to make sure we haven't lost them. Sorry, I think we've lost.
Hello.
There we go. Just lost our slides.
Yeah, sorry. I'm going to restart my page.
That's okay.
Is it back?
Looks like it. So we just jump onto the next slide.
Yeah.
Excellent. So when we look at this slide, we can actually see the amount of moisture different activities that we undertake create in our home. So this data is from Brands, the Building Research Agency for New Zealand. And they looked at what our activities do to create moisture in our home, and I believe it was a 4-person family. And what I found curious here is that cooking and breathing were actually on equal terms. So you can think the amount of cooking we do, we see all the moisture coming out when we're cooking, right? Or maybe we're cooking a soup or roasting something in the oven. You see the steam come out of those things. But breathing, you don't see anything. And yet we're doing that all day, even overnight, and overnight's really critical. The moisture we generate in our bedrooms is what the condensation is formed from on our windows. And so breathing is a really massive part of the contaminants in our home. Other things that create moisture, if you're drying washing inside, really critical. The best way to dry washing inside is to actually put it in the bathroom and run the extract fan if you have to do it. I'd far prefer you not dry washing inside at all, take it outside. And if you've got a dryer, you realistically should have, sorry, I've got a pop-up. Realistically, should have it exhausting to outside. And by exhaust, I mean removing the air from your laundry space. But 5 litres a day, pretty major. In fact, 5 litres per load. So maybe you've not done it every day, but 5 litres per load. Another one that I find quite interesting, showers and baths, 1.5 litres per person. So that essentially is, I believe it was a 15-minute shower. So it's a reasonably long shower, but if you've got a teenager at home, again, maybe that's part of the problem. So 1.5 litres per person per shower. And if you've got an ensuite, you're most likely to have more moisture coming out of that space into your bedroom than not, especially if you don't leave your bathroom fan running after your shower. So that's something else you can do. If you are having a shower, you finish up and you haven't got all of the moisture out of that space, or even if you think you've got most of it, leave your bathroom fan running 10-15 minutes after your shower, or we'll talk about continuous ventilation a little bit later today. And then the last one, I find this a bit fun. You know, when you've just done your dishes, you've finished with the dishwasher, and you open it up, and rather than letting it dry inside, you open it up to let it air dry. Well, all of that's releasing that moisture into the room. So what I like to say is it's really not healthy to do dishes. Let's just stop. No more dishes, no more living in our home. We'll just all move outside and the home will be perfectly fine. Unfortunately, not really the reality, which is why we have ventilation. Now,
I'm just going to stop you there for a little bit because we have a few people just join us. So I'm just going to re-inform what's the topic for today. 好，那我们看到有一些朋友们现在加入到我们的公开课里面然后我们今天主要的主题是关于新风系统。现在我们在讲就是家庭潮湿的一些成因，以及我们的室内的空气质量有很多的因素去导致，然后我们的新风系统是怎样能够帮助大家把这些不良的因素都规避掉的。好，那我们下一个应该会讲的就是关于室内的空气的潮湿湿度。Okay, sorry, back to you, Storm.
Brilliant. So what we've just moved to now, we've just finished talking about the ways we might generate moisture in our home, which was flowing on from different reasons we might use ventilation. But what I'm talking about now and what we're looking at is how we actually measure humidity in our home and how we understand humidity. So in our everyday lives, what we probably see in our weather app from the news will tell us a relative humidity. And relative humidity is just one way you can measure humidity. So down the left-hand side of the screen, what we have is 3 different main ways that I like to talk about humidity. So the first one, relative humidity, it is relative. It's a ratio. So it changes depending on the temperature of the air. So air at different temperatures can hold different amounts of moisture. So it's a percentage of water the air can hold up to 100%. Whereas what we actually want to know a lot of the time is the real amount, the actual amount of humidity in the air. And that's our absolute humidity. So that's the second one down, our AH. And absolute humidity is a better measure of the amount of moisture. If we took a cube of air and we pulled all of the water out of that cube of air and put it in a glass and weighed it, that would be how much actual water is in the air. If we change the temperature of that air, and we don't change the moisture content, that actual humidity will stay the same, but your relative humidity will change. And then the last one I've got on there is something called dew point. And dew point is really interesting because it is essentially a measure of, it can be compared to relative humidity in that it's the stage at which you have 100% relative humidity. It's a temperature where you will get condensation. So at 100% relative humidity, if you cooled the air down anymore, you would get condensation. So dew point is that point where you will get condensation if you cool down to that point. Same with if your surface temperature gets down to that level, that's when you're going to get condensation on that surface. So what we've got is a worked example here where we step through some different temperatures and how it actually works. So the first one at the top of your screen is 22 degrees. And what we've got is a 100% full, the yellow dots are the moisture in the air, 100% full cube of air. And that has 19.4 grams of moisture in it. So that's how much water is actually in the air. And if I were to cool that down at all, so if I go below 22 degrees, which is the dew point for that cube, then I would get condensation. But what we do first is we actually warm that air up. So we take that air and we take it from 22 degrees to 24 degrees. And you'll see there that the relative humidity is now 89% relative humidity. But the absolute humidity has stayed the same at 19.4 grams. Same with the dew point, that stayed at 22. So we know now that we've warmed the air up, the volume of the air, the amount of water it can contain has got bigger, but nothing else has changed. The actual moisture hasn't. So then we're going to cool it down. So we take it down to 15 degrees. So we've gone from 24 degrees or even 22 degrees down to 15. And you can see here that we've stayed at 100% relative humidity because the air is still saturated with water. It's still full of water. But what we've got instead of 19.4 grams is we've lost about 7 grams of water. And that's our green dots around the outside of that box. And so what that means is when I cooled my air down, I lost moisture in the form of condensation. And my relative humidity stayed the same, but my dew point also decreased. So 15 degrees is now my dew point. Now I'll use another example to that in a moment. But before we do that, we're going to talk about a healthy humidity level in a home. Because you don't want 100% relative humidity in your home. It's not going to be good for you. It's far above where we really want to sit. So a healthy humidity level, if you measure it in relative humidity, is around 40 to 60% RH. Now, if you measure it in dew point, it's around 10 to 15 degrees dew point. 10 to 15 degrees is a lot easier because relative humidity does change depending on the temperature. But if we're looking at that 48% relative humidity on that last line in the last row, we've got 9.3 grams of moisture in the air and we're sitting at 10.5 degrees. So this is a healthy humidity level. If I warm that up to 24 degrees, I'm still sitting within that healthy range, 40 to 60, so 43%. Still got the 9.3 grams of moisture, and I'm still at 10.5 degree dew point. Now, if I cool that down to 15 degrees, what's really interesting is I now appear to be outside of my healthy humidity range at 72.5%. So 40 to 6%, I'm now outside of that. But I've still only got 9.3 grams of moisture and 10.5 degree dew point. So what we're saying here is that actually at these temperatures, at colder temperatures, you can have a healthy air and still get condensation. But you can also have, when the air is colder, you've got less moisture in it. So if we go to the next slide, I explain it in another way that may make more sense to you. What I find is sometimes you'll see this and you go, I'm not quite sure if I'm getting it yet. It's often quite good to revisit it or to think about it when you're at home and you're actually seeing condensation or you're experiencing it at home, to kind of go through it in another way. So here's one other way we do it, and then I'll take you through one other example as well. So the air inside your home, let's say this was built up in summer, let's say it's 25 degrees and it's currently sitting at 80% RH. Maybe you've been cooking all day or you've had a lot of friends round. And so the moisture in your home is built up. So at 25 degrees, it's 80% RH and it's got around 16 grams of moisture in it. Outside, it's cooled down a little bit in the evening. It's actually sitting at 20 degrees outside. It's still at 80% relative humidity. But at 80%, 20 degrees is only 11.69 grams of moisture. So the outside air has less water in it, despite being the same relative humidity. If we were to then bring that outside air inside and warm it back up, so we brought that 20 degree air inside and warmed it back up to 25. 25 is my comfort zone, might not be your comfort zone. Huria and I quite like warm, but some of the other guys in the office would far prefer it at 20. But regardless, we bring that 20 degree air inside, we warm it back up, and now what we've got is we've got a 25 degree air with only a 58% relative humidity. So what we're saying is essentially when you bring air inside, you dilute the air in your house and you dry it out by bringing in drier air. Now, one of the things that's come up is, why does that actually matter? Like, how does this relate to me? I understand that I don't want condensation on my window, but why do I need to dry all of the air in my home out? And so this is where it gets really interesting. The example that I've found has worked for most people is a wet t-shirt example. So if you were to wear a wet t-shirt, you understand that you feel quite cold in a wet t-shirt. And if you try and warm yourself out, say with a hairdryer, you can tend to get like a hot spot, but it doesn't dry you out, and it takes quite a long time to warm you up. And if you take that hairdryer away, you immediately lose all that heat because it radiates off you. So if you would instead think about wearing a dry t-shirt, maybe one that's just come out of the dryer, so it's got a little bit of residual warmth, and you were to then try and warm yourself up with a hairdryer, then what you'll find is you warm up quicker, you stay warm longer. So what we tend to say is a dry home is like living in a dry t-shirt, and a damp home is like living in a wet t-shirt. So when you add ventilation, what you're looking for is moving towards living in that dry t-shirt. So it's a lot more comfortable. Happy to go over this a little bit more later, because I do know this is one of the most challenging topics that we talk about. Now, once we've talked about humidity, then we start having a look at our actual home, so the quality of our home. And what we've got is a graph here, also from BRAND, so the Building Research Association. And what they did is they did a study of homes over the last 60 years and looked at their air tightness. And air tightness is a measure of how much air is going to be able to move through the building envelope. So that's through natural gaps in your walls, around your windows, under your door, through your floor. And what they do is they pressurize the house and they test how much air is actually going to move out of that house at 50 pascals. And you can see here through this box and whisker graph, the main line to look at is the horizontal line in the middle between the two, the blue and the purple, or the little dot. So that's your median and mode. Median and mean, that's your actual average and middle numbers. So you can see in the old house, the pre-1960s home, that the air change rate was around 18 ACH. Now, a lower number is better. So since pre-1960s, we've actually come all the way down to around underneath 5 ACH. So it's about 3 times better. And that's really massive. So what we're looking at is, in both old and new homes, we know ventilation's an issue. But it's even more of an issue now in our new builds because our houses are so much more airtight that we don't have any natural air movement. Interestingly, what we're relying on in our building code is that we open windows or the air moves naturally throughout the course of the day. So ventilation is becoming more important. If you've got a new build and you're wondering why you've got condensation in a new build, it's because there's not enough natural air movement happening inside your home. Right, so these are all building blocks to why we have ventilation, but what we're actually going to talk about next is the different types of ventilation systems that are available. We move on, I think just 2 slides forward. So we're going to talk about 3 different types of systems: a mechanical extract ventilation system, a positive input ventilation system, and a mechanical ventilation with heat recovery. And I'll try and explain to you the different ways these systems operate. So if we have a look at the little picture on this next screen, you can see from the different houses that the houses are responding differently. Do you mind stepping to the next slide, Lily?
Yeah.
Excellent. So what we've got here is 3 different types, and I will be using continuous ventilation solutions. The reason for that is that you don't just want to rely on an intermittent solution. The reason what an intermittent solution is that's one you only turn on when you think you need it. So it's like only putting the filter on your fish tank when you're feeding your fish, or as we do at home, only turning the fan on when we're having a shower. So a continuous ventilation solution that's always on, and it's designed to provide a whole home outcome. So it's improving your air quality all of the time throughout your home, but it means it needs to be very energy efficient. And with those systems, we've got our mechanical extract ventilation system. That's a continuous extract system. So it's pulling air out of your house all the time, creating a negative pressure. Next to it, we have a positive input ventilation system that's pushing air into your house all of the time, creating a positive pressure. You can see the house is puffing up versus the negative one, which is sucking in. It's becoming skinnier. So negative pressure sucking in, sucking the air out, positive pressure pushing air in, so puffing up. And then beside it, we have something called mechanical ventilation with heat recovery. And that's where we've got both an extract system and a supply system working in tandem. And what we're actually doing with that is we're crossing it over, and I'll talk to that in a minute. But if we look specifically on the next slide at the mechanical extract and positive pressure systems, what we're looking at is negative versus positive, but we're actually creating a vacuum inside our home and puffing the other one up like a balloon. And when we do that, we need to put that air in and pull it out of the right places. So what I've called that is dirty spaces or service spaces. That's essentially your wet areas like your kitchen, your laundry, and your bathroom. So with negative pressure systems, you want to be sucking the air out of your dirty spaces, your wet areas. And the reason for that is that if you were to push air into those spaces, say in the shower room, you push air into your bathroom while you're having a shower, then you're going to push that air all through your home. So you don't want to push the moisture into the rest of your house. Just like in your kitchen, you don't want to push your cooking fumes into the rest of your house. You want to suck them out where they've been created. So we put negative pressure in our dirty spaces. For positive pressure, we're pushing air into the house. So we've said we can't put it in our bathroom. We need to be putting it in our clean spaces. So that's our living rooms, our bedrooms, and our studies. And if you've got positive pressure going into your clean spaces, it's kind of like when you think about in a hospital, if you have a surgery room, you want to make sure you're filtering the air before it goes in. So you're pushing air into the room and you know it's clean because you know where it's come from and you know what filters it's gone through on the way in. And also when you positively pressurize a space, that means you're not going to get any other air rushing back into the room. So with a surgery room, you don't want the air rushing in when you open a door. Another example for positive pressure is if you have a master bedroom with an ensuite, you wouldn't want negative pressure in there because if you don't have negative pressure in your bathroom, you create negative pressure in your master bedroom with that ensuite. If you are having a shower or if you've left any moisture in that bathroom, it'll pull that air through from the bathroom. So that's why we positively pressurize our bedrooms. Then if we look at positive pressure versus mechanical ventilation with heat recovery, it's a slightly different story. So the good thing with mechanical ventilation with heat recovery, as I said before, is it's both supplying and extracting at the same time. But something that's really interesting is that a lot of the time people have thought that you need to use mechanical ventilation with heat recovery only in new homes and you use positive pressure in old homes because old homes are leakier. Now, that is a general way of understanding it. Sorry, I think we need to jump on to the next slide. Just realised I've continued off on my own track. I do that sometimes. So if I've jumped ahead, someone jump their hand up and let me know. So yeah, positive pressure, old homes and new homes. What we're looking at there is that positive pressure does in some ways suit old homes better unless you're going to plan gaps. So we talked about air tightness before, and this is one of the reasons why I like to talk about air tightness first. is that if your house is too airtight, you have nowhere for that air to leave via. Just like with continuous extract, you have nowhere for that air to come in. So really we're looking at some of those older homes, maybe there's a little bit of a gap around the window, so at least you know the air is going to be exiting the building where you want it, rather than recirculating it inside the house or pushing it into spaces that you don't want it. The other comment with positive pressure when you're comparing it to heat recovery is that it suits temperate climates quite well. And the reason is that when we're bringing air in from outside, what positive pressure is doing, it's a supply-only system. Supply-only meaning just putting air in. When you're bringing air in from outside, we don't necessarily get the opportunity to energy efficiently treat that air. So maybe you want to heat it. If you put an electric heater on, it's going to cost you quite a lot to heat. So in a temperate climate, you have to spend a lot less on heating than you would in a cold climate. In a cold climate, if it's 0 degrees outside and you want it 20 degrees inside, that's a long way to go. Now with positive pressure systems, they do often, the now ones do use roof air to help warm the air up a little bit, but you can't guarantee that warmth. And you often want that warmth on the coldest parts of the year. And overnight, what we get is we actually lose a lot more heat from our roof space. So often those systems slow right down. And we know that we need to be moving that air all of the time. So we actually want to be looking at the heat recovery solutions as the best outcome for our home, because we're both removing the contaminants like we needed with the intermittent and the continuous extract, and we're supplying good quality fresh air into our home, and we're creating a balanced solution. So we're not forcing our home to respond in a way it doesn't want to when it's too airtight. Now that works in both old and new homes. You just see less of the benefit in an older home because you have more leaks. So the relativity is different, but the actual payback, the actual benefit is the same. Even more important in a colder climate, because when you do that heat recovery, what's happening is you've got air coming in and air leaving, and they cross over. So we've got the two pathways and we cross that air over. And essentially when they're crossing over, it's a little bit like a handshake. It's like someone's coming in from outside, they've got a cold hand, and someone's inside with a warm hand. And the longer they leave those hands in contact, the more warmth is going to pass from one to the other. Nothing else passes between, but the warmth goes between one and the other. And so what we're doing with heat recovery, it's like a handshake, and you've got that energy coming across and you warm that air coming in. It also works in summer. So if you've been cooling inside your house, then if you've got cold air leaving and warm air coming in, it'll help to cool that air down on the way in. But it is designed to temper the air. It isn't a heater or a air conditioner. It's just tempering it with that energy you've already generated inside your home. If we go on to the next slide, I've lined them all up for you just to kind of help summarize it all. So what we've got is mechanical extract ventilation solutions, the continuous extract solutions. They're a very good solution for contaminant removal. So they're for your bathrooms, your kitchens, and your laundries. And you do need removal in those spaces. That's a requirement of building code. But you don't get to control the fresh air coming in. You create a negative pressure and it sucks air in from outside of the home, but you don't know where from. So very important to kind of recognize where you're putting that one. With positive pressure, it's for your clean spaces, your living rooms, your bedrooms. You're pushing air into the home, and you can treat that air. You put it through a filter, you can even put a heater on it, or you can choose to heat transfer air around your home. But we don't know where the air is leaving via. Now, you could put two of them in. You could put a positive pressure system with a negative pressure system and run two independent systems, kind of like we do in most homes when you have an extract system and you install a positive pressure system later. But that's a pseudo-balanced solution, so you don't actually check that they're doing exactly the same amount of air in each direction. What we really want to go to is the controlled extract and supply solution of heat recovery, where you've got two similarly sized or the same size fans, and they're running at the same time through that handshake of the ceramic, of the core inside the heat recovery unit. And that is the most energy efficient ventilation solution available. Right. With those, now that we've got a good backing for what types of systems are available, we'll have a quick talk about what actually you can get from SmartVent. So SmartVent does offer positive pressure and heat recovery, and in our extended range from the Cymex family, we have continuous extract solutions from our Manrose and our Ventaxia brands. So we have a look on the next slide. We'll have a look at the continuous extract solutions available from Manrose and Ventaxia first. Lily, could I get you to go to the next slide, please?
Got it.
Excellent. So what we're showing here is a continuous extract solution. And you can see in the little picture of the house in the corner, they've got one external penetration and a whole lot of air coming in through the natural gaps or the planned gaps if we put a passive vent in. And we're not going to cover passive ventilation or trickle ventilators today, but that is something else you can do coming into the house. And what we've got on the left is our single room solution. So if you're trying to remove contaminants from a single bathroom, maybe you've got an apartment in only one room, or you've got a townhouse with a downstairs toilet, or you've already got an existing house but you're just replacing one fan, or you're trying to move to a slightly more whole home solution but you're not quite ready for a positive pressure system yet. So with the single room solutions, we've got two main options, although there are more in the range. We've got our EC contour fan, and that's ceiling mounted. And the wonderful thing about this EC contour is it actually has replaceable faceplates, so you can choose the look for your space and you can change that over time if you'd like. And it's very, very efficient. So that system there costs less than about $8 a year to run on low fan speed. So very effective to run and very quiet to run because it doesn't need to run very fast. There's not a whole lot of air movement noise. The second one there, the Genius, is another wonderful single room solution that has app control. It's got temperature sensing and humidity sensing and occupancy sensing, so it's not going to nuisance trigger on you. And so you can control those settings when it's going to run, and that goes through the wall. So if you can't go up through a roof space, you can actually install this straight through the wall and straight to outside. And because it's running all of the time, you don't need to worry about backdraft shutters. Have you ever had one of those fans with a backdraft shutter that flaps in the wind and makes clattering noises? Well, one of these, with it running continuously, you don't need to worry as much because it's actually going to be on all of the time, so you're not at risk of having air coming back in unless you're in a very, very high wind zone, maybe up at the top of the hills in Wellington. Next to it, we have a more whole home solution. So the MultiVent's a wonderful solution. It's one very unique solution on the market in that it's a built-in box with 3 extract spigots and 1 exhaust outside. What that means is you can actually install it and serve 3 spaces at once. So while the system may seem a lot more complex, when you finish off the overall install, you can often save some money there. The biggest saving is really in those exterior penetrations. So instead of having to install a penetration per fan like you would with the EC Contour or the Genius, and by penetration I mean a hole to outside, you can get away with just the 1 exterior penetration for 3 spaces. And actually if we do a design for you, and we do designs for these, if you are looking for a MultiVent design for a development, we will do a design for you. You can actually get away with 1 exterior penetration. Maybe you've had to go through the roof or you've got to put a weather cowl in. You can actually bring your kitchen, your bathroom and your laundry all through the one system, and that's got a built-in humidity sensor as well. Now the benefit of those built-in humidity sensors is that it's going to boost that speed up when the humidity, and particularly in a shower or in the bathroom, goes above a set level. So very effective solution, and again also very cost effective to run. Now once we've seen those continuous extract solutions, we start having a think about what we want to do with our supply side. So if we go to the next slide, we're going to have a look at some of those features that we start bringing in when we can control our fresh air. So I've talked a little bit about humidity already, but on our supply side, because we're sensing not just the air leaving our home, with a positive pressure system we can sense at multiple places and control where we're choosing it from, we're able to introduce something called dew point control. And what that does is it recognizes the real humidity levels in the air and picks the best source for the air and changes the fan speed to bring in the right amount of air at the right time. Now that's very important for energy efficiency, is controlling that demand level. If you cause overventilation, if you move too much air at once, you might cool your home down or heat it up. When it's too cold outside, you'll cool it down. When it's too hot outside, you might heat it up by bringing in too much air. So we want to bring in the right amount of air, and dew point control is a very critical part of that, particularly when you're trying to manage moisture as well. Next to that, we have something called an EC fan, and both of those, all 3 of those systems I showed you before, they use an EC fan as well. It's a more energy efficient fan. So an EC fan is going to cost you a lot less to run than an AC fan. Now it stands for electrically commutated, if anyone wants to get into the details of it, but the easiest way to explain it is sort of like a brushed versus a brushless motor, and it uses a computer to choose how much power it's actually going to use. So it's very efficient, and especially on part loads, an EC fan is very efficient, and it typically lasts longer. So that's the way most of these continuous ventilation solutions are going to go, is that they're going to have a lot more EC fans in them, and we've certainly done that here at SmartVent. Next to that, we have something called acoustic ducting. And acoustic ducting is something that you won't see in most ventilation systems, but we believe it's very, very important. And the reason for that is through your ventilation system, sometimes you won't hear the fan at all, but you'll get air movement noise, and that's the air moving through the duct. With an acoustic duct, what happens is that noise bleeds out into the ducting rather than coming into your house. So it stops noise moving down the system. It also stops fan noise moving down the system. We actually did an experiment on Friday with a group of electricians where we set up a whole lot of acoustic duct and we attached a fan to one end. We got them to put their ear at the other end of the ducting. Now, if you had nude ducting, that noise would have echoed down the ducting, but with this system, you didn't hear it at all. We got them to hand it round and listen. So yeah, it really reduces the noise through the system. So acoustic ducting, very important. The other thing we have is insulated ducting. So if you've got acoustic ducting, it will be insulated as well. And that insulated ducting becomes really important when you're adding a heat transfer system or a heater, because you want to make sure you're retaining all of that warmth inside your ducting. If you have nude ducting, then you end up losing that warmth straight back out into your roof space. The next three systems, or the next three features, are called comfort features, or I call them comfort add-ons, and their real benefit comes into their own when you're looking at improving the comfort of your positive pressure system. So with a summer feature, or what we're now calling a flexi air source, that's looking at what that best source of air is and changing between the roof space and outside. The real beauty of it is over the summer when it gets cooler overnight and your house is warmed up because it's all trapped inside, you're going to be bringing in that cool air overnight. So it's a free way of cooling your home rather than having to run your air conditioner. You just need to run the fan on your ventilation system, which is also bringing in fresh air. Heat transfer is a little bit different. It switches to running the air from inside your living room out through to your bedrooms, and we specifically put that in to suit places with fireplaces. So it's most recommended for fireplaces or any other high quality source of heat. Potentially have a gas heater, but please make sure it is a flued gas heater, not an unflued gas heater, because unflued gas heaters generate moisture in the space. That's some of the waste from gas when it turns into heat. But a flued gas heater, and you can take that warmth, and you want it at least 26, kind of 30 degrees in that living space before you take it out to your bedrooms, and we share the warmth around your home. Then if you are finding the air that's coming in through your positive pressure system is getting a little bit too cold, you can add a tempering heater. Now this isn't a whole home heater. It is designed to take the edge off the incoming air. So if the air is coming in at 5 degrees, maybe it's been a very, very cold night, or you live in the bottom of the South Island, you might want to bring that air up a few degrees. So you might want to bring it up 3, 4, 5 degrees. That's what that tempering heater is for. It's not going to make your home 20 degrees. But as we talked about before, drying out your home makes it more comfortable. So don't worry too much about that heating side of things, because it's like living in a dry t-shirt. You're going to feel a lot more comfortable at those colder temperatures if you're dry than if you're wet. So if we now have a look at the actual systems that are available, which are on the next slide, we can see the three different types of systems available in the positive pressure range. So the positive pressure range has the Light Plus, the Positive 3, and the Positive Advanced. And there are some really key differences on who we target those at. But before we get into too much of that, we'll talk about the types of features available in each. So we jump on to the next slide. We've got all the differences available in those systems. So what we're looking at here is the number of rooms it serves and what kind of kits they come in. And we do all of that with your electricians, or your electricians do that for you. If you're an electrician, we can help train you on how to select it. Or our product guide is very good at supporting you in that as well. It's designed to help you work through it, and I can show you guys that a little bit later. What we've got next is the features. So we've got a light system, and that really is targeted at your investor or your rental property, or someone who's really looking at a budget, just wants to deal with managing the moisture reducing condensation of it. It's only got standard ducting. It's not got acoustic ducting. It's got a little bit of acoustic ducting, but it's not through the whole system. And it's got an AC fan. So remember, we were saying that an EC fan makes the system cheaper to run than an AC fan, so it will cost you a little bit more to run a light system. With the Positive 3 system and the Advanced system, they both have acoustic ducting through the system, and they have that EC fan, and that's a good European motor out of one of our sister companies. So we work with a European group. Then we've got the different control features. So we've got temperature control, low temperature protection, and boost. And what that means, particularly low temp protection, is when the temperature outside does get very cold, it changes how the fan speed responds. We do the same thing at the high end. So if the air in your roof space is getting too hot, we'll also either slow down the fan speed or turn it off depending on your settings. And you're able to set the temperature. So it's not controlling the temperature of your home, but controlling the temperature that you're targeting with your incoming air, and that affects what the fan speed logic is going to do. When you've got it running in auto mode, it's going to follow that logic. If you put it in manual, you can actually choose your own fan speed. Then we've got a few more differences. So we've got the different humidity sensors. And what we've got there is that we've got 2 times humidity sensing on the light, and that's a fully wired solution. So there's one wired heat sensor in your roof space and one wired sensor inside your wall controller. On the positive 3, you get wireless sensors, which is really useful because it means we can install them in better locations, and it includes an outdoor sensor so it can do that dew point control for you. Now, the 3rd sensor is actually built into your wall controller again, and what that means is with the positive 3 and the light, you need to put that wall controller in an occupied space, probably your master bedroom or your lounge. And the reason for that is those are the main spaces we want to look after, so we need to know the temperatures in them. With the advanced, you actually haven't got a sensor inside the wall controller. You get 4 wireless sensors. So those 4 wireless sensors, one goes in your lounge, one goes in your main bedroom or the main room of concern, one in your roof space, and one outside. And that gives you the best sensing overall throughout your home for the best control of the house. And because you've got no sensor in the touchscreen, you can put it anywhere in your home. So maybe you don't want it in your living room. You'd prefer to put it in your hallway or your study, maybe even in your garage. I've had some people do that. As long as the installer can get a wire there, you can put that advanced screen somewhere. But why would you do that? Because it's such an attractive screen. I really like the screen on the advanced. It's very easy to use. It's very self-explanatory. So it's actually got text alongside the icons. We've found some people can struggle with remembering what the icons do. But actually with the positive 3 and the advanced, beyond that, you can move towards using the app. So if you are struggling with the screen, you've got the app on your cell phone. The installer can help you set it up, and that allows you to do all the same controls that you would get from your wall controller. So we've talked a little bit about the screens and the app. The other thing that you get is different types of scheduling between those systems, and a rental lock on the Light Plus and the positive 3, but not on the advanced. You can still lock the screen, but not a rental lock. And the rental lock, again, really targeting those investors, will allow you to make sure that they can change the set temperature, but they don't get to turn the fan off. And sometimes people think if they turn the fan off, their house will be warmer, but they forget about the benefits of drying out their home and protecting their home. So rental lock stops them from turning it off. Now, I talked before, if we go to the next slide, about the comfort add-ons. And so the other thing I'd really like to let you know is that the light, you aren't able to add any comfort add-ons like you can on the positive 3 and the advanced. So if you're a homeowner, or if you've got an investment property but you might live in it one day, then I'd highly encourage you to always start with the positive 3 and the advanced. I wouldn't look at the light for those spaces because it doesn't give you the opportunity to change any of those comfort features that you may find you want later on. So that's the key differences on the positive pressure system. Because those are the most popular systems, I will pause briefly for any questions there before we move on to the heat recovery.
Okay. Is there any questions that we have? Sorry, just another pop-up for me as well. So I think there might bring a few more audience to the webinar. So I'm just gonna do another brief kind of summarize of what we've done. 刚刚看到有很多朋友刚也加入到了我们今天的公开课里面。我们现在正在讲关于SmartVent 的2个新风系统。我们已经讲了第一个是正压式的新风系统，然后大家在屏幕上可以看到我们有3个不同的型号 Light、Positive以及 Advanced， 然后屏幕上也有一个对这3个系统比较简短的总结。如果说大家对这个系统有什么样的疑问的话呢，可以在评论区通过登录后花园的方式来给我们留言，或者说如果您不方便登录的话，我们的微信群里面也可以让您来提问，或者说有任何 comment 想要留下来，我们这边也可以看得到。那么 目前屏幕上的这3个选项的话呢，我也要替观众问一下，就是大概的价格的区间是什么样子。Okay, so because these 3 systems are really popular, so I'm just gonna ask on behalf of the audience, in terms of the price differences, is there any chance that you might give us an idea, or is that too tricky because it depends on the bedrooms?
Pricing is very, very hard, but I can give you a bit of a step difference between a 4-room system on each.
Okay.
So if we're thinking kind of the Light Plus, you might be sitting, and this changes, so we don't do the install, and the install varies on every home. So just take this kind of with a grain of salt. So a 4-room light system might start at around $3,000 installed, including GST. Where a positive 3 system might be an extra $500 to $700 on that same 4-room. If we then looked at the advance, you're spending another kind of $500 to $600 as well. So stepping through them, it's about $500 to $700 difference between each type of system. I really encourage you to consider those differences, particularly the positive 3. That is our best value solution because you do get that fully acoustic insulated ducting, you get the Wi-Fi app, you get the advanced, the wireless sensing and the dew point controls, and you have the opportunity to add those comfort add-ons. And those are really quite critical, particularly in your own home. For the advanced, if you want that easier to use system, a little bit more controllability or better monitoring of your home, and monitoring is really interesting because we learn a lot about our home, then the advanced is worth going up that next step as well.
Okay, cool. Thank you. 那么对于我们现在正在观看公开课的观众们来讲呢，其实大家都知道新西兰的这个潮湿房屋的环境啊，其实会影响在你们的居住体验。所以不管您是有投资的项目在盖，或者说是这个未来为自己的爱家在考虑说我怎么样去维护房屋，或者说有比较舒适的居住的这种环境的话，其实这种新风系统都是您不管是现在还是未来需要考虑在内的一个非常重要的因素。好，那我们现在会来讲另外的一个系统。
Excellent. I think we can go past that slide because it was good having the information up on the slide while we were there. So the next bit we'll talk about is our heat recovery systems, and we've got 5 different heat recovery systems, but we break it down to 2 and 3 systems because they have different types of applications. So if we look at the first 2, we'll be looking at the single room heat recovery system. So these are designed to just deal with one room. Now, before I forget, the one on the right, the Fresh, that's coming out in approximately July. So it's on the water at the moment on the way to New Zealand. We're very excited about it landing soon. So the difference between these 2 systems, the Tempera and the Fresh, the first difference I'm going to point you to is actually the simultaneous versus push-pull. So simultaneous means the air is moving in both directions at once. So you can do that for a single room install without unbalancing that room. Whereas with the Fresh, it's a push-pull. So it'll push air in for 75 seconds and then it will pull air out for 75 seconds. So you can't put it in a bathroom because you don't want to push air in. Whereas with the Tempera, you can push air in and pull air out at the same time. So you can put it in a bathroom or in a garage. We don't want to push air into the garage because it might bleed into the rest of our house. So you can put a Tempera in your garage conversion, or if you're using the garage, it's more of a living space. Another key difference is in the efficiency. So when we move from positive pressure to heat recovery, we start talking about efficiency of the core differently to the type of motor. So the efficiency here is how much heat you're going to recover. Now, interestingly, it looks here like the Fresh is more efficient than the Tempera, but the Fresh is determined based on the wall depth. So the Fresh is great in that New Zealand walls are quite skinny. In overseas and particularly colder parts of the world, they'll build their walls 200, 300 millimetres deep. In New Zealand, we use 90 or 140 millimetre framing. So the Fresh suits a 140 millimetre wall overall thickness. So that includes your external cladding and your internal lining as well as your timber framing. And so that suits most New Zealand walls. But on that skinnier wall depth, your efficiency is only going to be 72% because we have less time in contact with the air. Whereas with the Tempera, it's got quite a long tube. It's over 300 millimetres long. So you get quite a long tube. It's good on the service side of the house. So you hide it around the back rather than on the front of the house. And with that long tube, because the tube stays the same length regardless of the wall depth, you get that 80% efficiency no matter what you're doing. It also means it's got something we've called here a universal wall. So if the Fresh isn't going to suit because the wall is a little bit skinnier, then you can put the Tempera in. I recommend it for basements and kind of studio apartments. Whereas for the Fresh, I'd be looking at a whole home solution. The other reason I say that is that the Fresh will talk to each other. So the Tempera is really designed to be wired up, and it's got a pull cord. It's really just doing 3 speeds in that one room. Whereas with the Fresh, you've got an app, and you can connect it up to additional wireless sensors, and it talks to each other. So you zone it up to 16 units in one home, and you can group them in sets of 4 so that 4 will be putting air in, while 4 others might be pulling air out, and then they'll reverse at the same time. So it's designed to do the whole home all at once, but through the wall. So if you've got a townhouse where you've got a downstairs space, or you've got a multi-storey house, then the Fresh is a really good solution. Or if you just don't have any roof space, or maybe you've gone architectural or skillion ceiling, then the Fresh is a good through-wall solution for you. If we, when we're sizing it, we tend to have a look at the amount of air required per room, but both of these will suit a single room application. If we go to the next slide, I've just got a quick summary of where I'd put these. So with the Tempera, I'd be looking at, as I said, those basements, bathrooms, studio apartments, any sleep out, maybe you're running an Airbnb, basically any space you want independently ventilated and you can't positively pressurize it, or you don't want to positively pressurize it. With the Fresh, it's really a whole home solution. So over a whole home, you're still not going to be positively or negatively pressurizing it as long as you pair it up. And so with that, you've got your whole home solution, good for townhouses, apartments. So again, apartments being through wall, you might have a couple bedrooms and then the living room on it. And then anything else that has no roof access, or in a retrofit solution where you can't get a ducted heat recovery system in. So it's a very flexible solution there. Now, talking about the ducted solutions, we've got them on the next slide. What they are is they're essentially quite big boxes with 2 fans built inside them. And they have that core where you do the crossover in it. And we've got 2 different types of system here. So 3 systems, but 2 different types. So we've got our horizontal and vertical models, and their difference. The other difference between them is that our horizontal model is also something called an energy recovery model, whereas our vertical model is a heat recovery model. And the difference is that in the energy recovery model, you have a paper core. So it's a permeable core, which means if you put it in a very humid space like a bathroom, not such a problem. And if you're just doing it for your house and you're trying to help control moisture in a house, not a problem. But if you've got a bathroom, you get that moisture going through that core, it can make that core damp and you can get mold build up. So we wouldn't put the Synergy into a bathroom. Whereas with the Balance and the Iconic, that would suit your bathroom application. So what you can actually do is you can replace your need for a bathroom fan when you're doing a new build by putting in a Balance and taking the continuous extract out of your bathroom and then supplying air into the rest of your house. So it's a really good, complete whole home solution. Now you'll see there that when you go from the Synergy to the Balance, you also change up through the efficiency quite a lot. So we go from 75% to 90% efficient. Depending on the age of your home and what your priorities are, that may matter to you. I find it really important. I think the Balance is a very good outcome. And we're actually bringing out, so the Iconic's coming out in about July. Again, it's on the water at the moment. Bringing out another system that's even more efficient again. And if you're dealing with a high performance home or a passive home, or if you're looking at doing solar and EV charging on your house, the Iconic is the type of system you want to add because it's got the extra app control, it's got additional wireless sensors you can add, and it is the best solution available. Now, talking about app control, the Synergy does have app control. It runs on the same software as our advanced system. So very, very good intuitive wall controller for wireless sensors and the SmartVent Smart Life app. And then the Iconic runs on the Vent Axia platform. So there's slightly different app platforms there. The Balanced is a very basic control, but that's not a problem with this one because all of the smarts are built in. So actually, when you get a good ventilation system, sometimes we prefer you not to play with it. And we say that because what can happen is you think you're changing the settings to make it more comfortable. What you're actually doing is you're essentially forcing the system to turn off or turn on to a very low speed when we really want it running a little bit faster. So often I'll say trust the system. If you are finding that it's not doing what you're expecting, we have an 0800 line that you can call and they'll help you through the settings. And 99% of problems can be resolved with setting tweaks. Now, the last thing on here that I'm really going to talk to is the add-ons. So with the Synergy, because it is that little bit less efficient, you may want to add the extra comfort add-on. So it's 75% efficient. You might have 5 degrees outside, 20 degrees inside. That 5-degree air, when you put it through the energy exchanger, will be coming in at maybe 14, 15 degrees. So it's a lot warmer and you haven't had to put an electric heater on. It's just gone through that core. But you might want to bring that up a little bit more with the heater, with the heat transfer, or in summer you want to add in that summer, the flexi air source. Now, on the balanced and the iconic, they actually come built in with something called a summer bypass or a bypass system. And what that means is instead of going through the core when your outside air is at a nicer temperature to your inside air, so say it was winter, but it's a nice sunny day in winter, and because you've got really well insulated home where you've kept your curtains shut and you forgot to get the solar gain, or maybe your house is orientated poorly, the house has actually ended up colder than outside. You don't want to put it through the core, because what will happen is it'll actually start cooling that air down because your house is colder. So you want to bypass the core. Same with summer. If outside is cooler than inside in summer, so it's warmed up because you have got a wonderful solar gain, your house is orientated fantastically to the north and you've got a lot of north-facing windows. So you've got all the solar gain, your house is warmed up. You might want to bring that air straight in from outside and it will bypass the core. So what we say with the balance and the iconic is they're really good whole home complete solutions. The synergy is a bit more of a built-up solution. So we go to the next screen, we'll have a look at what how we stage those different solutions. So the synergy is really a base solution. It's for living spaces only, not for your bathrooms. And it's good energy recovery solution with optional add-ons. If you're looking for a more complete whole home solution with heat recovery, that bathroom option as well, and that extra energy efficiency, the balance is a good step. But if you really want the best, and when you're looking at heat recovery systems, often you do want to go to that higher level of efficiency. You want that extra performance and controllability. The app, the iconic is the best for you, and it's absolutely one of the best on the market. I love it. Now, one of the questions I often get is that if I am doing all of this work with a ducted heat recovery system, what about a heat pump? Where do I get my heating or cooling from? So if we go to the next slide, I just want to let you know a little bit about one of the ways we can hook up to a ducted heat pump. So there's a lot of different ways you can do it, but if you are looking at a ducted heat pump, there's no reason you can't get a ventilation system as well. And actually, I highly recommend putting in a ventilation system as well, or instead, is that a heat pump is not designed to deliver fresh air. What it does is it recirculates air around inside your home. The air that's leaving is going through the heat pump and back into your house. It's not actually bringing any new air in. So we recommend integrating the two. So what we've got here is a mechanical ventilation with heat recovery, maybe like a balanced or a synergy, hooked up to the return air side of your heat pump. And then it runs through the heat pump and through to the rest of your house. So the heat pump does that extra little heating or cooling if you need it from the outside air, if the heat recovery hasn't brought it up to the temperature you want. And then it distributes it through the same ducting, so you don't need a second set of ducting. Now, there are different schools of thought on this. The compromise we make here is that you will have to leave the fan on your ducted heat pump running. You don't need to run it in heating or cooling mode, but because the resistance, and this is getting a little bit technical, so feel free to follow up with me later, because the resistance inside the ducted heat pump is so high, we need that extra boost from the ducted fan. So you will have to run that fan, but in a well-designed solution, that won't be a problem for you. And if you have a ducted heat pump design, or you're doing a ducted heat pump job and you'd like a heat recovery system added, you can actually send us your designs and we'll add a heat recovery system in, and you'll see what components you need to do that job. So really, really good outcome integrating those two. Cool. So what we've got up next is just a summary of all of those systems at once. So we're then looking at how they really sit in the market space. So with the SmartVent Lite, it's a basic solution. It's very entry level, targeted at investors. Then we've got the Positive 3, and as I said before, that is our best value solution. The Positive Advanced is the superior control solution. So when you're looking at positive pressure, that is the best option from the positive pressure range. Now, if you're looking at heat recovery and you're caring about energy efficiency a little bit more and comfort a little bit more, you've got your two single room solutions, the Tempera, that's very targeted, specific, designed for that single room. Whereas the Fresh is a bit more modular. Even though you install it in one room through the wall, you link it up through your whole home. So it becomes your whole home modular solution. And maybe you can install 2 of them this year and another 2 next year if you're thinking about which spaces you need them in. Then you've got the Synergy, which, as I said, is a built-up solution. It's a good quality solution, but if you really want to go that little bit further and do your whole home, do a complete solution, the step up is to the Balance. And then if you want the best of the best, the Premium is for you. Cool. Okay, so I'll just tell you a little bit about the SmartVent services, and then I've got a quick slide on what training we offer as well, because we do training for our accredited installers. And so if you've got an electrician friend who you'd like to use for your home, but they haven't done an installation training or they'd like some more ventilation advice, then we do, pardon me, we do training on that online regularly throughout the month. We also have that design service that I mentioned. So if you do want a ventilation design for your house, there's no charge for that. Or if you're working on a development, we can help with that too. And we can also do building code, healthy home compliant designs, or high noise, medium noise zone compliant designs for acoustic requirements. As I said, accredited installers nationwide, and we've got the training program. And then we've got an online selection tool, and that's really targeted at taking you through what we think your home needs. So based on the size of your home and the age of your home, we will give you a recommendation. But as I said, if you feel like you'd rather go to heat recovery and it's recommended your positive pressure system, don't be afraid to make that change. We do have a few finance options available, as well as the banks at the moment have their green home loans or healthy home, sustainable home loans. And those are at very low margins. So one of the banks is actually at 0% and the others are sitting around about the 1% mark. So you can put a ventilation system on those types of loans, or we have Q card available. And then, of course, the 0800 line. So if there's anything I've talked about today that you want to ask more questions on, do get in touch with it. But before we finish up, I'll just take you through those training courses. So if we jump on to the next slide, the training courses we do, we've got a Ventilation 101. It goes into a lot more detail on the humidity stuff we covered earlier. It talks about filtration, types of fan systems, how to choose a fan system, and the specific fan performance criteria. We spend a lot more time on the different ventilation systems. So that's a very, very good training course that runs for about 2 hours. We've also got the product training, which you'll have seen today. So this is covered pretty much all of the product training. We've got an in-person installation training that our reps run throughout the country. And then we've got coming out later a troubleshooting training that's specifically targeted at electrical installers, and a sales and specification training to kind of help people select the right product for you. All right, we'll leave up on the screen for you the complete lineup while we go through questions.
Cool. Thank you so much for the presentation content. And we've got a few questions just on the screen and also at the back end. So we've got a person asking that, I don't know what he means by all the bathrooms or including kitchen vent, but I think he's asking like for a certain system. That question popped out when you were going through a certain system. So I think his question is kind of about like, does all the bathrooms need to have that installation to have certain achievements, and does that include kitchen vent? I can't really recall which system he's asked.
I think I can answer that one. So with the continuous extract solution, well, a couple of things. With building code requires us for a new build to install a bathroom fan in every single bathroom. So that's if it has a shower. Essentially, if you've got a toilet space, then if you don't have an openable window, that also requires an extract fan. Laundries, if they have a dryer, must have an extract fan. If they don't have a dryer, they don't require one. And then kitchens must have a range hood. Now, in the code, it requires a certain airflow, but if you go to a separate alternative solution, you can use continuous airflow, and that's a lower air volume. So it's quite a lot of air in the intermittent version, and it's a lot less. So 50 litres a second from your kitchen in intermittent, and only 12 in continuous. In bathrooms is 25 and then 10 in continuous. And so you do need to put it in all spaces. Same thing for healthy homes. They have all the same requirements. The only difference is that they look at the diameter of your fan as well, in case you've already got a fan installed, and it's a lot easier to measure the diameter of your fan than it is to measure the airflow. So the healthy homes, the only difference is how you can check if your current system is compliant. And healthy homes is that one. If you've got a rental property, it must be healthy homes compliant, and there's a ventilation requirement there. With the continuous ventilation solution that I showed earlier, the multi-vent that does multiple spaces, yep, it suits a kitchen, bathroom and laundry all at once, even a bathroom, toilet, kitchen and laundry. It will be running a fan out of those system spaces all the time, creating that negative pressure. And if it senses any high levels of humidity, it will boost up and all those spaces will be boosted together. But the good thing is that you've got only that single penetration. With the kitchen one, it does essentially remove the need for a range hood, but what we recommend is putting in a recirculating range hood. And the reason for that is we do have grease coming out and smells coming out of our cooking. And so we want to capture those in the range hood rather than sending it through our ventilation system, because it can clog up that motor, especially as often those systems don't have filters installed on them. And filters are really installed to protect the fan motor. So it works in there, but it would be an alternative. But quite good if you don't want to take a 150 or 200 diameter penetration out for your kitchen as well.
Yeah. There's quite a few questions he's asking, but I think it probably apply to most of people's kind of question. So one of it, which relate to what you're just talking about, is he asked, like, do you combine all the vents in your system? So for example, if it's a renovation kind of project, they already have some fan that's used for the bathroom and the laundry. And if they want to do a bit of extra, then can those fans be part of the system, or it will be running separately?
So if you were doing a continuous extract solution and the fans were still working, you wouldn't need to replace those fans. And if you were to put something else in, you'd actually probably take those fans out because they wouldn't be helping them because they'd be running separately. But you can reuse the penetrations in your ceiling. So you could reuse the ceiling grill penetrations. And the wall grill penetrations, depending on what solution you are installing. Probably if you're working on something like that, definitely worth getting in touch either through the 0800, or I think, Lily, you could supply the inquiries email afterwards as well.
Yeah. Well,
just let us know that you've heard information through here, because then I'll let the team know. I'll be able to fill them in. But it really does depend. If you're looking then at a whole home solution and you've already got bathroom fans, you might not choose to replace them. That is up to you. You could just move to a supply system with an extract system there. If you can upgrade to a continuous or a heat recovery solution, then I'd go that far.
Yeah. Okay. Because of time, we may have to kind of move on.
Okay.
But there's another one that's relatable to maintenance and also changing filters. This will probably get asked a lot because my colleague was wondering about it. He has one at home. Just like, how often do you have to change the filter at all, and who does it?
Yeah. So on a continuous extract solution, probably won't have a filter. On a positive pressure solution, definitely does. We recommend about 1 year. I tend to recommend in the first year, check after 6 months. If your filter is very dirty, maybe you live next to Queen Street in Auckland, so it's a very busy street, you might find yourself changing the filter more often. But typically, if it's reasonably clean, wait till the end of the year. There's an algorithm in the system that sends you a reminder as well. And you can do it yourself. Or if you'd prefer not to climb into the roof space, as I know some of us wouldn't be too keen on that, you can get your installer or a friend to come around and do that switch out for you. And then you can reset that filter warning yourself as well. So you don't need any special code or anyone from us. We'll tell you how to do it. And we've got some videos online on how to change the filter too. And so both the heat recovery and the positive pressure definitely need filters changed. And it is about once a year.
Yeah. Okay. I still will have a few questions I have to go through. If Storm can just keep it kind of short and sharp for us, because we're running out of time. Yeah. Thank you. So another question that came through just on WeChat is someone asked, what is the minimum roof height for SmartVent?
Cool. So through the wall ones, don't worry about the roof space at all. So we've got options for that. But if you're putting it into the roof space, definitely a minimum of 400. More is better. If you like your installer, more is better. If you don't like them, whole nother story. If it's a new build, not a problem. Just make sure you design in a little bit of space to put the fan, and then the ducting's typically 150 diameter. But yeah, 400, a good way for roof space is a minimum.
Okay, cool. And another live question that just came in is someone wants to ask, what is the price range for the second system? So what's the English name for it? The heat. Yeah, the one on the screen on the right. So what is the price range for those?
It's sort of the one on the screen on the right, the heat recovery. Oh, okay, sorry. The heat recovery range. Look, quite challenging on the temper and the fresh. You'll probably be sitting around 1.5 per room, maybe 1 to 1.5, depending on the complexity of the install. On the heat recovery, the synergy and the balance, the synergy is starting around that 5.5 to 6 point. Again, varies per home. And then you've got, so these ones, so synergy, the one on the left with the control system, 5.5 to 6 at the starting point for a 3-room and up from there for more rooms. And depending on the size of your house as well, the balance is starting more at about 7.5 heading up. But when you start adding add-ons to some of those other systems, you'll find you head towards that price anyway. And because the balance is a complete solution, sometimes it actually comes out more cost-effective and a better energy efficient outcome, and you pay it back. You save that money over time anyway.
Mm-hmm. Cool. Hope that answers the audience question. And there's also a few questions we clicked before the webinar, which we already went through 2 of them. And next one is there a guide to the recommended or minimum amount of air changes for a room per hour?
Yep, so just very quickly, the building code sets that up as 0.35 ACH, which means that you take the volume of your house, the floor area, times the roof height, and times it by 0.35, and that'll do you meters cubed per hour. And you can convert that into litres a second. The other part of the guide is actually 7.5 litres per second per person. Those are both designed for minimum requirements. So I tend to size it on low fan speed at those minimums, and then you go up higher beyond that.
And then the next one is, does the positioning of the outlets in each room make much difference to the performance?
Yeah, so if you put the outlet by the door, what you end up with is the air never reaches the window. And if you're looking at condensation management, then you don't get any movement of air around where you're getting the condensation. So you want to put it closer to the window. It tends to be between the middle of the room, about halfway between the middle of the room and the window, and about 1 meter out from the window. You also want to be careful about putting it over the bed head so that you don't get any drafts on you. If you've got a warm system coming in more towards the center of the room, and it changes the type of diffuser, but avoid being near the door.
Okay, cool. And then the next one is, does the system transfer internal heat around my house so I can keep rooms at a stable temperature?
So controlling for a stable temperature is a little bit challenging with ventilation, but we can move heat around the home with the heat transfer system. Obviously, the faster you move that air to that space, the more effective it's going to be. Heat recovery, similarly, it's going to help maintain that temperature, but it is bringing in air from outside. So depending on how cool that is, you will affect your temperature. So as I said, do recommend integrating them. If you're going for a very high performance system, integrating them with a heat pump as well.
Mm-hmm. Yeah, and the very last one is probably more like a homeowner kind of perspective, which I know is a little bit hard to answer, but I'm still going to ask. What are the typical running costs for this type of system, and what are the potential savings in the heating costs in winter? I probably assume it depends.
Yeah, it really does. It depends. I mean, do you have an AC or an EC fan, a heat recovery system, or a positive pressure system, or a continuous extract system? As we said, the continuous extract, $8 a year was tiny as a running cost. I've also seen systems that are kind of that $20 to $40 a month. And then with the heat recovery system, what we've found is that if you're reducing the amount of heating you need, or with a positive pressure system, you're reducing the amount of heating you need, we get a lot of people saying, hey, it might be using more energy to run, but I'm actually spending less money, so I'm actually heating my house less. So it's very hard to put a number on it. As I said, maybe $10 on a continuous system to run, but you might save some energy because your house is drier. Heat recovery, though, we can actually see effective savings between positive pressure and heat recovery. So you're saving anywhere between $1,000 to a couple thousand a year, depending on how you run your home and how you heat your home.
Yeah, and overall, I think using any sort of SmartVent is to improve your health and also to improve your living environment. And I think that's pretty priceless. And it probably will save you money in terms of maintaining your house for long run. So yeah, just for a homeowner, they kind of have to prepare themselves for the cost and also for the money they're throwing in. Anyway, that has been a really, really great presentation. Thank you so much, Storm. Just like to say a few words to the audience as well. 今天我们这个公开课的直播内容其实可以说是非常非常有价值的，因为不仅我们了解了房屋的潮湿以及就是不适的这种原因，它的 后面的成因是什么，以及我们了解到了不同的新风系统它是怎么样帮助我们的家庭获得干燥的或者更舒适的这种居住环境，以及我们了解到了在不同的项目上，不管您是自住房、投资房，还是说未来想要去为自己的房产增值，或者说是减少维护成本这样的过程，然后我们都有非常不同的系统的选择。好，那么今天我们非常高兴能够邀请到 SmartVent 来带来我们对这个产品跟系统的一些分析。它不仅仅是一套这个通风换气的系统而且我更认为它是一道坚实的去守护您和您家人健康的盾牌。通过今天的讲解，相信大家都对自己的房子适合什么样的系统有了更好的概念，让拥有一个这样健康舒适的家居环境变成了一件更简单的事情。好，那么非常感谢2位嘉宾到场然后如果有什么样的问题，也欢迎通过后台给我们留言，然后我们未来也会给大家带来更多有意义的公开课的内容。Okay, thank you ladies for joining our webinar today, and hopefully to have you back soon for some other useful education. Thank you so much.
Thank you so much for having us, and thanks for joining us. Cheers.
No worries. Thanks everyone, and I will see you shortly in the future, hopefully. Thank you. See ya.
Bye.